Hello, my name is Lisa Munoz, and I will be going over the introduction to the project Exploring the Unconscious. The team members for the project were Kam N and myself, Lisa Munoz. The product owners were Dr. Mario Eraso, and the professor was Dr. Masood Sanjadi. So the problem that the project faced was we all have personal questions. Naturally, we come up with possible answers to these questions. The struggle lies in deciding which answer best suits our question, and the solution we seek is often locked within our unconscious mind. However, we are disconnected from that unconscious mind. Kam worked on completing the shell for the Android application and integrating the algorithm code. He also implemented the sound and sound preferences and implemented the input validation and error handling. Lisette refactored the version 1.0 algorithm code to be integrated into an Android application, integrated the final application design, and collaborated and implemented the verbiage for the tutorial and about pages. Both Lisette and Kam collaborated in creating the final UI design and created and implemented an algorithm that converts time in the format of 12 o'clock a.m. into alphabetical text. So for the first sprint, we managed our time in which we had to go over sprint 1.0. We learned Android development and we both created many applications, well, too many applications, and uploaded them on Bitbucket. As you can see here, we have the Gantt chart for that. Then below you see the Sprint 2 Gantt chart, where we went ahead and refactored the previous source code, integrated the existing algorithm into Android Studios, changed the app's output, also worked on the time conversion algorithm, the testing of the algorithm, fixing any of the algorithm bugs we found, supporting all time entries, researching Carl Jung's aesthetic, and creating a design based on that research. Now you can see the Sprint 3's Gantt chart where we created a second design, fleshed out the design chosen by the product owner, added chimes, added music, provided sound preferences, and integrated the design into the application. This was a two-part process, so part 1 was done here. Then for Sprint 4, we worked on fixing the algorithm bugs and creating the documentation from the previous sprints, something we need to take a whole sprint to catch up on. We also finished integrating the design during this part time. For Sprint 5, as you see in the Gantt chart here, we tested the application on an actual phone, we fixed the bugs that were found, we made the application responsive for the main page as well as for the response page, and we changed the icon. And finally, for the last sprint, we recorded and added the voice, we fixed the verbiage issues that were found in the tutorial and about page, we added a same question button. We went ahead and created the poster, the PowerPoint, and the final documentation, as well as completed any of the bug fixes that needed to be done by the end of the project sprint. So we had a total of 6 user stories. The first user story being integrating the existing algorithm into Android Studios, then integrating sounds into the application, the tutorial page, the about page, input validation, and creating a basic Android application for the project. This wasn't necessarily done in this exact order. So going over the first one that I mentioned, which was integrating existing algorithm into the Android Studios, we had the use case, which was the name, comparing inputs into the algorithms. The actor was the user, and the precondition was, as a user, I want to be able to compare my question and answers from compatibility on a mobile app. The description here we have is the user clicks on the Explore button, the user types in their input in the 4 text boxes, which all have options, and the user clicks Compare button. Finally, then the application takes the user to the results page, showing each answer's compatibility with the question. The exit condition is if the user clicks the back arrow in the compare screen, and the exception to that is if the user input does not follow the valid input formats. Here is some visuals on that. And here we have our use case diagram, which shows the actor going from the Explore screen to the input screen to the compare screen, and then finally getting their results. And we have the sequence diagram, which pretty much shows the same thing. We also have here the class diagram, which shows the process going from the main activities page all the way to the end, the results activities page. The next user story we have here is integrating the sounds into the application. The use case here is change sound preferences. The actor being the user and the precondition being, as a user, I must be able to turn off and on the music, voice, and chimes on a settings page. The description being, the user selects preferences from the home page. The system displays a page showing 3 toggles from turning the music, voice, and chimes on/off, and the exit condition being the user returns to home screen through phone back button. The exception to this being if the user clicks a different button. And here are the visuals for how that looks, from the home page to the preferences. Here is a use case diagram showing how the user goes from clicking preferences all the way down to being able to toggle the chimes, music, and toggle voice. And here we also have a sequence diagram to our right showing the turning off of the chimes. Here we have the class diagram showing the process of that as well. Next we have the tutorial page where the use case is navigating to the tutorial page. We have the actor, which is the user. There are no preconditions for this, and our description goes as follows, which is the user selects tutorial from the home page. The system displays a page showing verbiage on how to use the application. The exit condition is the application successfully navigates to tutorial page, and the exception being user clicks a different button. Here we have the visuals on that. And here we have to the left the use case diagram, which shows the user clicking tutorial and navigating to that page, as well as a sequence diagram for that as well, to our right. Next we have our class diagram, which shows going from the main activities page to the tutorial page. Next we have the About page, where the use case is navigating to the About page. The actor is the user, and there are also no preconditions. The description goes as follows. The user selects About from the home page. The system displays a page showing verbiage on how to use the application, and the exit condition is the application successfully navigates to the About page. The exception being is if the user clicks a different button from the About button. Here we have the visuals on how that looks like. And here we have the use case diagram to our left showing the user clicking the About page and navigating to the About page screen, and we have the sequence diagram showing that as well to our right. Here we have the class diagram showing the main activities page navigating to the About page. And here we have the input validation use case, which is handling user input. The actor is the user, and the preconditions is the users are in the Explore page. The description goes as follows. The user inputs a correct input, i.e. only alphabetical letters and time format, and when the user leaves the text box, their input is checked by the app. The exit condition is if the user clicks the Compare button or if the user clicks the back arrow button. Exceptions being if the user types in special characters such as the question mark or percentage character, or if the user types in numerical values that are not in time format, such as the number 1, 2, 3, 4, 5. Here on the screen we have the visual user guide showing the images of how that looks like. And here we have to our left the use case diagram where the user is going in and putting in their input for the question and answers 1 through 3 and comparing. And to our right, we have the sequence diagram showing the user input validation. And here now we have the class diagram showing the navigation from the comparison activity to the time format validator. Lastly, we have create a basic Android application for the project. The use case name is navigate from main main page to output page, and the actor is the user. Preconditions being be in the comparison page. Our description is the user clicks on compare button, the user is then taken to the results page. Here is a visual for what was the basic application that was created initially. And then here is the use case diagram to the left, being the user going from the compare to the output, and here to the right is the sequence diagram showing the same. Now you see the class diagram showing from the main activities to the output page. So for the system design, our architecture pattern was MVC. The view and the controller is implemented, however, the current version has no database. As you can see to the right, our model, where the model includes the user input model and the user sound preference model, and then it continues to updates under view, which includes the home view, the explore view, the results view, the about view, the tutorial view, and the preference view. It then continues into the user input, which includes a controller, having the home view controller, the explore view controller, the result view controller, the about view controller, the tutorial view controller, and the preference view controller, and then it goes all the way back by modification into model. And now you see on the screen our deployment diagram. And finally, we get to the design patterns, where a singleton is used to control the playing of the sounds, and the conversion and validation of the input to be used in the algorithm is implemented through the use of chain of responsibility pattern. The user input is validated using validator classes, and then if it is past the validators, it then is converted into format required by the algorithm using the conversion classes. Some user requests can be treated as a state change similar to the preferences features, which changes the state of the app, enabling certain sounds and disabling others. So for the main algorithm, to determine if the inputted question and answer are compatible, find the first, second, and third digit for both the question and answer, respectively. Then compare the question with the answer to determine if they are compatible. So to calculate the first digit, here is the pseudocode, where essentially the first digit is just the length of the user's input. To calculate the second digit, each letter has a number equivalent, A equaling 1, B equaling 2, then I equals 9, and then we go back to 1, which is J equals 1, and we go all the way to the end of the alphabet where Z equals 8. We then, in a loop that is iterating through the user's input, parsing one letter at a time, we're saving the second digit to be whatever the value of the current letter is. So let's say the first word is about, then we're going letter by letter, and the first letter is A, so A equals 1, the second letter is B, which equals 2, and we're saving that into second digit. To calculate the third digit, we just add the first digit and the second digit that were previously calculated together. So finally, we compare the question and the answer. So the question is equivalent to whatever the question's first digit, second digit, and third digit is together. And then the same thing goes for the answer. Then for the comparison number, we just add the question and the answer together. So if the question and the answer share a digit as well as the comparison number, if all those three share a digit, such as the digit 2 or 1, then it is deemed compatible. If it doesn't share any digits, then it is deemed not compatible. So we had testing done. We did an input validator test, which is basically just checking that all of our validator methods worked properly and that all of our tests were passed. So just a quick description on that is, on the Explore page, enter into the question, answer 1, 2, and 3 fields in incorrectly formatted time input. Input that includes properly formatted time. This input can also have valid alphabetical input mix in the input as well. So then we have some examples following that below. And once everything has been entered, click the Compare button, and this will take the user to the results page. So our expected result for this test was when the user enters invalid input contains an incorrectly formatted time value, and clicks away from the input field, it will notify the user with a message that the input is invalid. So the result was that it notified the user that the input was invalid, and it wouldn't let them proceed to the comparison page. So our test passed. We also had an algorithm test, which checked if the methods created in our algorithm class were correctly being implemented. So one of our tests in the integration test was checking if the user is able to compare their inputs using the algorithm and see their results. And essentially this test was just going from the very beginning, where you go ahead and you input a question and 3 answers, and then see if you can get all the way to the results page without a problem, assuming that the user is giving them valid input. And it passed this exam. In summary, we created an Android application that uses Mark Moore's algorithm, and the application promotes mindfulness and helps the user connect to their unconscious. If you have any questions, both Com and my contact information is there. Thank you.